a sporting goods store sells reusable water sports bottles for $8. At this price, their weekly sales are approximately 100 items. Research says that for every $2 increase in price, the manager can expect the store to sell 5 fewer water bottles. We need to write a quadratic function to represent this. So this is a revenue question. We're trying to make money. So revenue is always going to equal the cost of your item times how many items you sell. Okay, so the cost of the item and the number of items you sold will give you your revenue, how much money you're going to take in at this store. So what I'll do is I'll circle the cost with one color. As you can see, there's a cost here, and there's also a cost here. So it says that if you sell the water bottle for $8, you can expect that for every $2 that you increase the price, you're going to lose some sales though. With another color, I'm going to circle now the number of items sold. So the 100 items is what I originally sold, but if I increase the price, I'm going to expect to sell 5 fewer items. So that's where the information is going to come. We have to make sure we separate the red from the green. Okay, one bracket will represent all the red numbers, one bracket will represent all the green numbers. So revenue will equal the original cost, which is $8. And the original number of items sold is 100 items. There's something we don't know. X is going to represent how many increases in price do we do. So how many $2 increases are we going to make this water bottle cost? So if I did a $1 or if I did one increase in this cost, it would be a $10 water bottle. If I did 2 increases in cost, that would be $12, right? So the water bottle is going to go up in price every time you make an increase in the price. So X is going to be the increase in your price. So the number of increases in the price. So it's telling me that for every $2 increase, meaning you're going to add $2 for every increase that you make, we can expect to sell 5 fewer, which is why I'm subtracting 5, times how many increases in price I make. Okay? So this is my quadratic function, but in factored form. My next step is going to be to actually do FOIL, to put them into your standard form. So first I'm going to multiply the first terms together to get 800. Then I'm going to multiply the outside terms to get negative 40x. I'm going to multiply the inside terms, positive 200x. And finally, I'm going to multiply the last terms together to get negative 10x squared. I can also simplify this, so I'll rewrite this as revenue equaling, in the proper order, I would have negative 10x squared first. I'll put my bx values together to get positive 160x. And we have plus 800, which is our constant. For B, it says they want us to determine the maximum revenue the manager can expect based on these estimates. What selling price will give us the maximum revenue? Something that would be useful is to change this guy into vertex form. Because if we can see vertex form, we can determine the maximum revenue and when that happens. Okay? So our next step will be changing that to our vertex form using the completing of the squares method. So step 1, put brackets around your x squared value and your x value, meaning your ax squared plus bx value. Next, I'm going to divide out the negative 10, which is in front of x squared, from both terms. So I'm going to divide out negative 10 from here and negative 10 from here, which changes your sign. So revenue is going to equal negative 10 in front of x minus 16x, leave yourself some space, plus 800. Once we factor out the negative 10, we're going to always take half the middle number, which is your b value, and square it. So half of negative 16 will be negative 8, and when you square negative 8, you should get positive 64. So you're going to add 64 and right away subtract 64. Next, we're going to take this negative 64 out by multiplying it by your a value in front, which in this case is negative 10. You need to multiply it by negative 10. So revenue is equal to negative 10x minus 16x plus 64. When we multiply the negative 64 by negative 10, we're going to get a positive number of 640, which we're adding with 800, because that was the number that was there already. So 640 added with 800. So revenue will equal negative 10. This is where I'm going to factor the inside bracket as well. So this is your standard form. I'm going to change it into factored form by always taking half of that middle number. So it's going to be x minus, so half of that number was negative 8. So that's going to be my minus p value. When I put these numbers together, I should get 1440. So that's your vertex form. Now that's going to help me determine the maximum revenue. So the first question is saying, determine the maximum revenue the manager can expect based on your estimates. That's your Q value. So this right here is your max revenue. The highest value that is going to reach money-wise. So the highest revenue is going to be 1440. So max revenue is equal to 1440. $1,440. Now, a common mistake that people do when they're answering the next question is they look at their p-value. The p-value is not really your answer. What selling price will give you the maximum revenue? This is your p-value, but that's not your selling price. Okay, this is only how many increases in price did you actually do. So you have to be very careful. Your p-value, you're going to have to take it back to your cost bracket right here. We know that the original cost of the water bottle was $8. So if we know that we made 8 increases in price to get to this maximum revenue, we're going to have to go 8 plus 2 times 8. Okay, so $8 was the original cost of their water bottle, plus 2 times, meaning $2 for every increase in price you did. You did 8 increases in the price. So at the side, to get the actual price of your water bottles, you're going to have to do $8 plus 2 times your p-value. So in this case, it's going to be 8 plus $16, which gives us $24. So that's your new cost of your water bottle. Cost of water bottle. So that would make sense, because if we took our cost of our water bottle, of $24 and multiply it by how many we actually sold, we could figure out the new price if we did that, okay? So we would have to take this bracket, 100 minus 5 times 8 to check. So if I took 24 and multiplied it by 100 minus 5 times 8, I would get the original price, the price that you would expect for revenue, which is $14.40. Okay, so that's a way of checking to see if your numbers make sense. If you plug your number back in, they should always give you your maximum revenue. How do we verify our solution? Well, we can graph the equation and check the vertex of our point. So if we graphed it, we would get an image that looks like this, and we can check to see if our vertex is 8 and 1440. So we can go into our calculator and find the maximum of our graph, as long as we set the window correctly. So this would be our checking method. So remember, P represents how many increases in price did you do, and your Q value represents the max revenue that you took in. Assumptions that you're making with this quadratic function in this form is you're assuming that, one, that it's a steady sale that you're always making. That if you go into the store, they're always selling a predictable amount. We're not looking for special situations, or we're not looking at like, oh, you know, on a Sunday they sold more than the other. We're looking at like an average price. So we're assuming that it's we have enough data to make this estimation. We're not just picking a single day and then assuming that they always make these sales, because some days will be better than others.